Hello everyone and welcome back to our videos. After we know the types of fire detection system and the smoke detection systems, today we will talk about the fire detection systems, inspection and testing, and maintenance. Fire detector sensing elements are located in many high activity areas around aircraft engines. Their locations, together with their small size, increase the chance of damage to the sensing elements during maintenance. So, damage can still result from vibration and handling during removal and installation. The following procedures are provided as examples of some general inspection practices that should be periodically accomplished on a typical fire detection system. We will start with spot type and thermocouple maintenance. Spot type and thermocouple detection systems are relatively simple to inspect and maintain. The individual sensing units should be inspected for security of attachment, dented or distorted housing, and electrical wire connections. However, when it's necessary to splice electrical wire between sensing elements, care should be exercised to only use the materials and splicing techniques that are authorized by the detection system manufacturer. In some installations, wire splices may cause a change in the electrical resistance of the sensing circuit, causing the system to malfunction. So you have to take care. What about the thermocouple detector? Mounting brackets should be repaired or replaced when cracked, corroded, or damaged. When replacing a thermocouple detector, note which wire is connected to the plus terminal of the defective unit and connect the replacement detector in the same way. After we talk about the spot and thermocouple detector maintenance, now we will talk about the continuous loop maintenance practices. One of the first items that must be periodically checked on a continuous loop detection systems is the routing and security of the detector elements. The distance between clamps on straight runs is usually between 8 and 10 inches and is specified by each manufacturer. We see here a continuous loop on the cowl of the engine, and here the distance between them, it must be from 8 to 10 inches. So as we say here, as or a loose clamp can result in interference between cowl press and sensing element. This interference can cause the sensing element to wear, which could create a short. A continuous loop sensing element should be checked for dent, kinks, or crushed areas. Nuts at the end of the sensing element should be inspected for tightness and proper safetying. In this figure, we can say the kink to the sensing element and we have a sharp bend. Also we have long unsupported loop, so here it must have a clamp, and we have a crushed section. All these things are malfunction of our sensing element. Also, when inspecting an electrical connector joint such as this one, verify that the retaining nut is properly torqued and the safety wire is secured. After finishing maintenance and inspection of the fire detection system, now we have to talk about some troubleshooting that happen to the fire detection system. Intermittent alarms or false alarms are probably the most common problems associated with the fire detection system. Most intermittent alarms are caused by an intermittent short circuit in the detector system wiring. False alarms can typically be located by disconnecting the engine sensing loop from the aircraft wiring. If the false alarm continues, a short exists between loop continuous and the control unit. Moisture is the detection system seldom causes a false fire alarm. Another problem that could be encountered is the failure to obtain an alarm signal when the test switch is actuated. Such failure could be caused by a defective test switch or control unit, the lack of electrical power, an inoperative indicator light, or an opening in the sensing element or connecting wiring.